This question combines the effect of temperature and resistance with the resistance of the material. And so if we wish to calculate the resistance for 40 degrees Celsius, the issue is that we don't know the resistance at any other temperature. And so if we use the resistance formula, resistance equals rho times length over area, remember that the resistivity value is valid for 20 degrees, and so we will find the resistance at 20 degrees Celsius. So that is our starting point. We have been given the diameter of the brass conductor as 1 millimeter. So we can write that as 0.001 meters, or 1 times 10 to the negative 3 meters. Now, the diameter is given, which means it's a round conductor. We can find the area by using pi times d squared over 4. And so pi can be written as 3.14159, or whatever your calculator produces. Multiply that by 0.001 meters squared divided by 4. That should give you an area 7.854 times 10 to the negative 7, and the unit is meters squared. Now, we must go to the table of materials and find that the resistivity of brass 7.00 times 10 to the negative 8 ohms times meters. We can put those numbers now into the resistance formula. Resistance equals rho times length divided by area. And we have 7 times 10 to the negative 8 ohms times meters, multiplied by the length, which was given as 5 meters, and divided by the area we just calculated, 7.854 times 10 to the negative 7 meters squared. Now, as always, the units are important. So in the numerator, we have meters. Meters cancels with meters squared in the denominator. So we will be left with a unit of ohms, which is what we expect for resistance. This should result in 0.4456 ohms. And remember, that is the resistance at 20 degrees Celsius. Now, if we wish to determine the resistance at 40 degrees C, we can say RT1 over RT2 equals 1 plus alpha 0 times T1 over 1 plus alpha 0 times T2. And alpha is the temperature coefficient, which for brass we will find is 0.00208, and the unit is ohms over degrees C times ohms, which we might agree is 1 over degrees C, or equivalent to that anyway. Now, our ratio typically will be written as RT2, where that is the resistance at 40 degrees C, is equal to RT1 outside of 1 plus alpha 0 times T2 over 1 plus alpha 0 times T1. And if it's written for that, then remember that RT1 is the resistance at 20 degrees C. So T1 is 20 degrees C. T2 will be 40 degrees C, as RT2 is the resistance at 40 degrees C. So when we write this, we can say R40 is equal to the resistance at 20 degrees, which we had at 0.4456 ohms, multiplied by 1 plus 0.00208 for alpha, multiplied by 40 degrees C, divided by 1 plus 0.00208 for alpha times 20 degrees C. Now, the most important thing to remember here is that this multiplication of alpha times T must be completed before the 1 is added in either case. And so, what we will do is say that this is equal to 0.4456 ohms outside of 1 plus. Now, the 0.00208 times 40 gives us 0.0832. The unit, if there's a 1 over degrees C in here for alpha, then this is, there's no unit on this. It's a fraction that we multiplies the resistance by to determine the new resistance. So in the denominator, 1 plus 0.00208 times 20 gives us 0.0416. Now we'll do the addition. We have 0.4456 outside of 1.0832 over 1.0416. Now, if we multiply out the numbers on top, divide by the number on the bottom, we should come up with the resistance at 40 degrees C is equal to 0.4634 ohms. That should be the resistance of that brass conductor at 40 degrees C.